Find the first and second derivative of y squared equals e to the x squared plus 2x. All right, so we're going to find the first and second derivative in this case. Right, we can try to solve for y, but we're going to get a square root. So I probably don't want to do that. Plus, it's a plus and minus, right? So we're going to get y equals plus or minus the square root of e to the x squared plus 2x. And then if we want to take the derivative of this, that's going to be a lot of work, right? So we don't want to do that. But instead, what we want to do is we want to use implicit differentiation, okay? We use implicit differentiation, which means what we're going to do is we're going to take the derivative with respect to x of y squared, and then we're going to take the derivative with respect to x of e to the x squared, and then take the derivative with respect to x of 2x. And these are straightforward, right? We just take the derivative as we normally would. But what about this? There's no x in this expression here. Right, so now this is the second thing, right? Whenever we do implicit differentiation, we are assuming that y is a function of x. So we would take the derivative of this as we normally would, right? But then we would need to multiply by the derivative of y, which is dy dx. Okay, so let's go ahead and do that. Okay, so derivative of this is going to be 2y, right, times dy dx. Okay, derivative of e to the x squared is just e to the x squared times the derivative of x squared, which is just 2x. And then the derivative of 2x is just 2. So this one turns out pretty nice, I guess, right? dy dx. Right, we'll just divide the 2 over, or the 2y over, I guess I should say, right? So we get 2x, e to the x squared, plus 2, all over 2y. You notice that each term does have a 2 in it, so I can factor out the 2 and cancel these 2's with that 2 down there. So here we go, right? This is our first derivative. Okay, then, well, wait a minute. How are we going to find the second derivative? Well, same thing. We just take the dy dx of both sides again. Now, when we do that, right, when we take the derivative of this, we're going to get d squared y, right? We're going to get d squared y dx squared, which is the second derivative. But now we have to find the derivative of the right side. Now, okay, we got a quotient, so we're going to have to do the quotient rule. For this guy, we're going to have to do the product rule, and so on and so forth, okay? All right, so let's take a look here. Maybe, I don't know, let's see. If we have a quotient, right, f over g, we want to find the derivative of a quotient. Remember what the quotient rule says. Okay, it's g times f prime minus f times g prime all over g squared. Okay, so we'll just do this on this side. Okay, so what is g, right? Remember, this is f and this is g down here, right? So g is just y times the derivative of the numerator. Okay, so we got to use the product rule on this, right? X times e to the x squared. So derivative of x is just 1, so we get e x squared, right, plus, and then let's see, we got to find x times the derivative of e to the x squared, which is, well, 2x e to the x squared. Okay, so that 2x will come out in front. That becomes a 2x squared over there. Okay, all right, that's just the g f prime, right? Now what about f g prime? So f is the, okay, that's good, right? That's just the numerator, right? So we got x e to the x squared plus 1 times g prime. Well, what is the derivative of y? Right, same thing, right? It's going to be just dy dx. Okay, so dy dx all over g squared, the bottom function squared, which is just going to be y squared. Okay, and remember, this is d squared y over dx squared. Okay, this whole thing here, this is the second derivative. So you're probably looking at this and saying, oh man, that looks pretty complicated, right? Well, it is. Okay, what can we do though, right? Well, dy dx, we know what dy dx is. That's the first derivative. So, for all intents and purposes, yes, we should plug that back in. Okay, here we can distribute the y, I guess, right? So we'll call that y e to the x squared plus 2x squared y e to the x squared. Now here we're going to put in, Right? Remember dy, we already got dy, right? That's the first derivative here, okay? So we'll put that in, right? X e to the x squared plus 1 over y times x e to the x squared plus 1, and all of this over y squared, okay? I mean, we could do a little something else, maybe get y on the denominator here and then bring that down, right? But for all intents and purposes, yes, this will be our final answer.